5. Go ahead.
Okay. All right, this is now the honors quiz. So if you're in honors and you watched the other one, there are a couple of different questions, so you need to make sure that you go through and you got all the right problems. So the first one was a system of equations. Gloria was weighing combinations of cylinders and prisms. The first measurement that she took was 4 cylinders and 5 prisms, and that was 32 ounces. And the other measurement was 1 cylinder and 8 prisms, and that was 35 ounces. So we have 2 variables. First, you needed to identify them. So we could say C is cylinders and P is prisms. And for the first measurement, there were 4 cylinders and 5 prisms, total of 32 ounces. And then there's 1 cylinder and 8 prisms for a total of 35 ounces. So there are 2 methods you could have taken. You could have eliminated. I probably would have multiplied all of this by -4 so that the 4 and the -4 cancel, and then you could solve for P. Or you could substitute, which is what I'm going to do. The C is nearly by itself, so if I subtract 8P, I would get C equals 35 minus 8P. Then I'm going to plug that in for the other equation that I haven't touched yet. So 4 times 35 minus 8P plus 5P equals 32. 4 times 35 is 140 minus 32P plus 5P equals 32. Combine my like terms and move the 140 to the other side, and I get -27P equals -108, which means P is 4, or 4 ounces. So then to find the measure of a cylinder, we would take 4 and plug it into here, or here, or here. It doesn't matter which equation. But I'm plugging 4 in for P, so I get 35 minus 32, which means C was 3 ounces. Good so far?
Yep.
All right, so the biggest mistakes here, people could set it up but couldn't solve it, which this is a linear equation and it's from Algebra 1. So if you can't solve that, that's something you need to practice. And then just not labeling the variables. Solving this system now, it's best set up for equal values or for substitution. Both of them are equal to y, which means we can set them equal to each other. A lot of people got this far. From here, we need to recognize that this is a quadratic. We have an x squared term and an x term, neither of which will cancel. So the only way to solve this is to set it all equal to 0, so bring it all to one side. We get half x squared minus 2x plus 2 equals 0. We could quadratic formula, or we need to factor. If we were going to factor, it'd be easiest to do if this was 1x squared. So we can rewrite this by multiplying everything by 2. So we get x squared minus 4x plus 4 equals 0. And then this is nice and easy. There's no term in front of x. So I'm looking for factors that are terms that would multiply to 4 and add to -4. So -2 times -2 is 4. -2 plus -2 is -4. And this is just the shortcut because there is no number in front of x squared. We could have factored this, and some people did try to factor this. Some people did fine, some people did not, and it was because of that half. So both of these are the same factor, which means we're only going to get one answer. X is equal to 2. Now from here, we need to look back up at what we were given. We were given 2 equations with 2 variables, x and y. We need to solve for both. So now that we have x, we need to plug this in and solve for y. A lot of people forgot to do that. So y is 3, which means our solution to the system is 2, 3. And then it asked you to explain what the solution tells you about the graph of the system. So we needed to say that 2, 3 is where the lines would intersect, or where they share the same solution. Something about explaining what that means to the system. Any questions on that one?
Not yet, no, you're good.
Okay. Solving equations. So there's 3 methods to solving. Graphing or guess and check is not one of them. We're solving algebraically, which means we can rewrite it. This means that we're doing something to the problem to make it easier. We're making an equivalent equation so that there's no fractions, or so that it's set up to factor, something to make it easier. But we're not going to do this if it's not going to make it easier. Looking inside is the cover-up, so we still need to do that step by step and show our work. Guess and check is not looking inside. So if I was going to use looking inside, I would need to still show step by step. And then undoing is probably what we've used the most so far, and I'm probably going to do that mostly through here. So first one, I can get rid of this -3 to start trying to isolate, and this is undoing. I'm using the inverse to bring it to the other side. And now this is kind of rewriting, also kind of undoing. I don't like this divided by y, so I'm going to multiply by y. All that's going to do on this side is cancel it, but I need to do it over here as well. Some people multiplied by y first. That's fine. You just need to multiply everything by y. So the 3 would have also needed to be multiplied by y. So I now have 6y minus 1 equals 5y. So now I'm going to get my terms together, minus the 6y. I get -1 equals -1y, which means y equals 1. And it also said to check your solution. We've been checking our solutions to avoid extraneous solutions. So if we did this graphically, by graphing this and this and finding the intersection, we would need to sketch that. If we did it by looking at the table, we would need to draw the table. If we did it algebraically, we would need to show that we plugged 1 in and we got a true solution. So some people got points off because they didn't check their solutions. And for the people who messed up their work, you would have realized that you messed it up. This one, we've got a -3 in front. We cannot distribute this into something that's being cubed. So again, distributing is not going to make this any easier. It's not undoing or looking inside. So we need to think about those methods. So if I divide the -3 instead, I would get 2x plus 1 cubed equals 64. From here, some people tried to cube this first for the millionth billionth time. You cannot do 2x cubed plus 1 cubed. That is not a thing. And then if I were to write this 3 times and try to distribute that out, that's not making it easier. So that's not using one of our methods. We want to think about undoing, or we want to think about the looking inside method would be asking ourselves, what cubed makes 64? So either way, if we undo or look inside, we get 2x plus 1 has to be 4. Some people said -4. -4 cubed is not 64, it's -64, so we have to be careful with odd radicals. And then from here, just solving. 2x equals 3, which means x is 3/2, or you could have written 1.5. And then again, we need to be checking our solution. So going back to the original and graphing these, we probably would have had to look at the table from there, or just plugging in 1.5 back to the original and making sure that this worked, and it does. Any questions on those steps or that process?
Not a thing.
All right. This one, biggest mistake is we didn't read the directions. It says graphically, which means we can use our graphing calculator, and we just want to put this into the graph. So it's one equation, but we're going to break it into two. This side of the equal sign will be this first equation. To get the absolute value symbols, we go to math and go over ABS, and we're going to type x minus 4, and then outside the parentheses is minus 3. Then our second equation is this right-hand side, which is 2/3 x minus 3. So when I look at the graph, I can see that they're going to cross in two places. Because it says show all work, I'm going to show that I graphed it. It doesn't have to be super duper accurate. But we've got 2 points here.
Okay, hang on a second. Remember, guys, this is the live video for Algebra 2 Honors. The Algebra 2 Regular has already been done. It will be uploaded to Schoology after this one is done. Again, this is for Algebra 2 Honors. Just kind of want to reiterate that.
So then we're going to look for where they cross. It's hard to see here, and the trace function isn't always super accurate. So I'm going to go to my table, and I know it crosses in the positive regions. So you can see at 3, they have the same value, and at 6, they have the same value. So they cross at 3, -1, and at 6, +1. But my solutions, when I look at the equation, I was solving for x. This was not a system. I did not have a y value. So my answer is x is 6 and x is 3, because those are the values that they cross at.
Sounds good.
Some of us tried to solve this algebraically and it was a mess. We just got to read the directions. All right, this one. This is straight from the homework. These are literal equations. So when it says to solve this equation for the indicated variable, this is the equation we're solving. And we're solving for the variable y. We don't know the value of x, and we're not looking for the y-intercept, which some of us thought that that's what it meant, so we plugged in 0 for x. We're just rewriting the equation so that y is isolated. So we don't need to simplify. We don't need to rewrite anything. We just need to move everything to one side so the y is by itself. So the first thing, we need to get rid of this entire thing. We don't want x minus 4 squared, so we're going to subtract it to the other side. And foiling that out is not going to help me at all. Now right here, the y is stuck in this squared, so I'm going to square root. And when I do that, I need to do that to everything. This is the square root of 10 minus x minus 4 squared, so it does not cancel with this squared. This doesn't simplify. There's no way to simplify this. So on this side, we have y minus 1, because it did cancel. The whole thing was being squared. On this side, I'm just going to leave it as 10 minus x minus 4 squared. There's no reason to simplify that. It doesn't simplify. Then I just need to add 1 to this side. So y equals the square root of 10 minus x minus 4 squared plus 1. This is solved for y. So we need to be practicing our literal equations because this was a mess. This was probably the worst one, even though it was probably one of the easiest questions. Also, because we took the square root, we can include a plus minus here, but I didn't take off points if we forgot that.
Good. Your people are quiet.
Okay. I don't know if that's a good or bad thing. This question is probably why we didn't finish our quiz, most of us. This all needs to be factored. But the nice thing about this is that these two expressions are easily factored because there is no value of
Wait,
A.
Abby Struther wants to know why you leave it squared. Go back.
So this expression does not simplify. We can't break up a square root to two terms. So it's just because that it's two terms, because of the minus, there is no way to simplify this. This, remember, can be rewritten as 10. Oh, hey, want to say hey to your
Hey, you want
principals?
to say hi?
We're going live.
We're going live, yeah.
This expression is similar to all of this to the 1/2. And we know that we can't distribute an exponent into two terms. So this is, remember, 1/2 is another way to represent a square root, and we're not allowed to distribute exponents.
Whereas over here, your squared was everything was squared, so the square root and the squared could cancel. Here, it's two different pieces. Hopefully that helps. You good, Ab?
We'll see. Okay, so these two expressions can be easily factored because there is no A value. So for those two, looking for factors of 16, that would add to 8. So 4 and 4 multiply to 16 and add to positive 8. For this one, factors of 24 that add to 10 would be 6 and 4. And then for these two, some people guess and check, that's fine. Some people box and diamond, some people slide and divide. Whatever method you use, it's fine. We had a lot of sign errors. So really be double checking that your final factors do FOIL to be the expression that you needed. So for this 5x squared minus 11x plus 2, I'm going to use these two, the first and the last, multiply them. That makes 10x squared. And then the middle is negative 11. So factors of 10 that add to negative 11 would be negative 10 and negative 1. So they multiply to positive 10, add to negative 11. Then in my box, I use the first and the last term from the original, and then the middle two terms that I found. So 5x squared, negative 10x, negative 1x, and positive 2. From here, I'm using the GCF of each column or row, and I'm making like my own multiplication chart. So 5x is the GCF of this row. Multiplied by x would make 5x squared. Then this would have to be negative 1 times x would make negative 1x, which means this is negative 2 times 5 would make negative 10x, and times negative 1 would make positive 2. So these are now my factors, 5x minus 1 and x minus 2.
One more time.
Now for this one, 10x squared plus 13x minus 3. 10x squared times negative 3 is negative 30x squared. 13x. Some people had a hard time finding factors of negative 30 that add to 13. Try making a list of all the things that multiply to negative 30 until you can kind of manipulate that. But it's 15x minus 2x. So in my box, I'm going back to my original first and last term, 10x squared and minus 3. And then my middle terms, and using my GCF for each column and each row.
Okay.
So here I have a GCF of 5x, here minus 1. Here I have a GCF where I can start multiplying. This would have to be 2x. Double check, 5x times 2x is 10x squared. Negative 1 times 2x is negative 2x. And then here, this would have to be a 3. 5x times 3 is 15x. And negative 1 times 3 is negative 3. So here's my factors, 5x minus 1 and 2x plus 3. Because this is multiplication, this is going to be one big fraction. So now that I'm in factored form, I've got this one big fraction. I'm looking for 1, the number 1 that I can cancel. So anything over itself. 5x minus 1 over 5x minus 1, x plus 4 over x plus 4. So I'm left with x plus 2, or x minus 2, sorry, and x plus 6 over x plus 4 and 2x plus 3. I don't need to distribute this out. This is fine. Any questions?
Not yet. You did lose 3 people on that problem, though. You're only down 14 now.
Okay. You guys can email me if you have any questions as well. This is a completely different problem. The order in which we do things is different. This is a subtraction. To add or subtract fractions, we need a common denominator. We have a common denominator. So we need to do the addition or subtraction first. So this is 3a squared plus a minus 1 minus the entire thing, 2a squared minus a plus 1. That was the biggest mistake right there.
Plus 2.
Is we didn't subtract the entire numerator of the second fraction. We only subtracted the first term. So we need to be careful with subtraction. 3a squared minus 2a squared is 1a squared. A minus a negative a is like addition, so that's 2a. And negative 1 minus 2 is 1.
Is what?
Just kidding. It's 3.
Oh my goodness.
Oh no.
Got it?
Yeah, okay. Now, some of us lost our denominator, some of us combined our denominators. When we add or subtract fractions, the denominator remains the same. So they don't combine, they don't go away, they don't cancel out, still there. Now from here, some of us simplified by doing this. We can only do that with factors, so we need to get this into factored form. Multiplies to be negative 3 and adds to positive 2 would be 3 and negative 1. Multiplies to 1 and adds to negative 2, be negative 1 and negative 1. Now we have a common factor, so we have a plus 3 over a minus 1.
Nice. Bada bing.
Okay,
It's a beauty.
fun stuff.
You're you've lost one more person,
Okay.
but no one's saying anything.
Good.
So we're gonna just kind of keep
I
rolling.
hope you guys are just really smart and you're just loving this. Okay.
Or
This.
they've got us on mute and they're scrolling somewhere else.
Transformations. We've been doing transformations for a long time. We should know that everything needs to be set equal to y. So as if I was going to type it into my calculator. This negative 3 that I'm moving over just needs to go on the end there. This negative 5 is connected by multiplication to all of this, so I cannot subtract the 3 from the negative 5. So I've got y equals negative 5, absolute value, x minus 6 minus 3. A negative in front, it does not affect the stretch or the compression at all. It just makes the reflection. So we have to use the word reflection, and we have to say over the x-axis. The 5 on its own is a stretch because it's greater than 1, not including the negative. The minus 6, that's an h value, so that's your horizontal. Translation is what we should be calling. Remember that it's always the opposite, so this is really going to the right. And then the minus 3 that you had to move over made it go down. So we're using the correct vocabulary, and we're saying in which direction or by how much. Here I need to divide everything by 2. So we get y equals square root of x over 2 plus 5. So this is a k value. For some reason, a lot of us thought that that was an h value. Horizontal shift would be under the square root within the function. It's on the outside of the function. So that's a k value. So that is going up 5. And then dividing by 2 is the same thing as multiplying by half. So that's really a compression or a shrink by half. So in order to get your points back, we should be taking notes on this. And then we need to go into Schoology and fill out the questions under the Unit 4 Quiz 2 reflection explanations in order to get your points back. That's your only assignment this week, so make sure you get that done, and we will see you after spring break.
Abby, did you hear her? She did say she's posting it on Schoology. She said it literally as you typed it, so I just want to make sure you heard her.
Yep, this will be on Schoology. So you can rewatch it, tell your friends to watch it.
Thanks. How do we know what questions we got right or wrong?
Yeah, you don't, and I'm not gonna send you an email with all of the pictures of your quiz, so I just want you to answer each question on the reflection. It's just, the questions are, what did you learn? So just make sure you're
And even if you
typing
got
in
it right,
something.
it could be as simple as I'll need to make sure I remember to factor properly or combine like terms. It can be something very like open-ended, even if you know you got the question right. There's still something you can take from every question.
Okay, love you guys, miss you, email me, but not at midnight. Good job, Ethan.